Hello everyone and welcome to another video with Special Maths Academy. We'll be looking at the third problem from the Special Maths Contest 2023. And it says 10 boxes are placed in a row. In how many ways can we put 5 balls, each of a different color, into these boxes? If each box can hold at most one ball and no two boxes without balls are adjacent. Okay. So first of all, this question is one of the very, I think like the only problem we had a typographical error. So it should not be different colors. Okay, so it should be the same color. But let's look at this problem. So let's look at, say we have let's say we have 4 boxes, okay? I want to put 2. I want to put 2 balls. So there are a lot of ways we can do it. So let me just replace let me use 0 to represent an empty box. So one way we can have 1 0 1 0, okay? Then we can have 1 1 0. Whereas 0 1 1 0. Then we can have 0 1 0 1. Okay, so these are 3 ways. And then if we look at 6 boxes and um and 3 balls, so we can have 1 0 1 0 1 0. Okay, we can have 0 1 1 0 1 0. We can have 0 1 0 1 1 0. We can have 0 1. So we're just arranging it as binary numbers in descending order. So I'll try to do this manually. We can have 0. Yeah, I think that should be it. Because any shift again and we'll have 2 zeros. Okay. So we can shift this first one here. So now let's look at it. So we have, let me say A, B, C, D. And let me say we have A1, B1, C1. Okay. So first of all, now we want to, try and merge these two. You get, 10 balls and 10 boxes and 5 balls. Okay. So we can have, so we can pair A and A1. Okay. So this gives, okay. We can't pair A and any other one because we'll have 2 zeros, so 2 consecutive zeros, and which will invalidate it. So when we can look at um, yeah. So we can now look at B. So we can have BA1. Okay, so these are now pairing. We can have CA1, it's not pairing, and we can have DA1. So these are not pairing. Okay. So these are the ones that end with A1. And what else can we look at? We can have so we already have BA1. Can we have B1? No, because it ends with a 0 and this starts with a 0. So we'll would have a violation. Sorry about that. Let me yeah. So we would have a violation. So we can have BB1. And similarly, we can't have BC1. So this is what it is. We can't have CB1 because C ends with a 0 and B1 starts with a 0. So we'll have 2 consecutive zeros. Okay. So, and similarly, we can't have CC1. Okay. So that leaves us with D. So let's look at D. So we can have DB1 and we can have DC1. Okay. Because D ends with a 1. And of course, you can actually try to, use some recurrence relation to like try to get the general formula for 2 n boxes and n balls. Okay. So now this is when we don't consider the color, we don't consider the balls to be different. So if the balls are identical, so we have 1, 2, 3, 4, 5, 6. Okay. So actually, when we talk of two n boxes and n balls, it's going to be n plus one ways. So this is something, we leave this as an exercise to the viewer to prove. So for 10 boxes and 5 balls, if, we don't consider, if the balls are identical, we'll have 6. So 6 will be the answer. And that is what should have been typed for this problem. But unfortunately, in the course of typing the question, so we put different color. So that's an error on our part. So now, if you want to consider when the balls are different, so different colors, then you have to, because there are 5 balls, so n balls, so we have to now multiply it by 5 factorial, and that's going to be 6 factorial. So basically 720 is the answer. Okay. So I hope you enjoyed the video, and don't forget to share, like, comment, subscribe, and see you in the next video. Have a nice one. Goodbye.